This is the screencast for section 1.7, example 3, protecting an antenna. A small satellite dish is packaged with a cardboard cylinder for protection. So in other words, they don't want this thing to smash, so they're going to put a cardboard cylinder in the middle so that nothing's going to dent the inside, etc. The parabolic dish is 24 inches in diameter, so all the way across 24 inches. And 6 inches deep, so from the top here down to the vertex of the parabola is 6 inches. And the diameter of the cardboard cylinder is 12 inches. So this cylinder is actually going to open this way, which was slightly misleading. It doesn't really look like that, does it? Oh, and then the reason I knew that was because if the cylinder was this way and the parabola was 6 inches deep, there's no way the cardboard could also be 6 inches deep, because then it would only be able to squish right here in the center. So I knew that the 6 inches had to be this way. That's the only way that there was room. How tall must the cylinder be to fit in the middle of the dish and be flush with the top of the dish? So we are trying to find this. Trying to find that. Well, I know that this is a parabolic dish. I also know that parabolas come in the form y equals k times x squared. I also know that this parabola is 6 inches tall at the end of a 24-inch diameter. So if I put that parabola on a coordinate plane, similar to this point over here would be positive 12 comma 6, and positive 12 comma 6, and this over here would be negative 12 comma 6, which still means a diameter of 24 and a height of 6. So I can come up with the equation of this parabola by plugging in 6 comma 12. 12 comma 6. So at this point, I have a formula representing the parabola of the satellite dish. I know that there's a cardboard cylinder in here that's going to come out to these 2 points, negative 6 comma 6 and 6 comma 6. The question is, how tall does it need to be? So if I find out the distance from the x-axis to the parabola, this, I can take 6, the total height of the satellite, subtract out this little mini distance, and I get the rest of what's left from the parabola up to the height of 6. Let me show you what I mean. First, I'm going to take, let's see, y equals 1/24 x squared, and I'm going to plug in 6. I'm going to find out how tall this little piece is. So y equals 1/24 times 6 squared. So y equals, let's see, 36, 1/24 times 36 is 1.5 inches. So there's 1.5 inches between the ground, basically, and the bottom of this parabolic satellite dish. So my cylinder inside gets to take up the rest of it, from the bottom of the cylindrical satellite dish all the way up to the very top of it. So I'm going to take 6 minus the 1.5, and I get 4.5 inches is going to be the height of that cylindrical cardboard shell. The now try problem number 35 asks very much the same thing as example 3 did. But now we've changed some dimensions a little bit. Now this parabolic satellite dish is 8 inches tall and 32 inches in diameter. So the dish is going to come out to negative 16 comma 8 and positive 16 comma 8. So a full stretch of 32 inches. Well, again, this is a parabolic curve, which comes in the form y equals k times x squared. And I have a point that this parabola goes through, 16 comma 8. So I'm going to plug in 8 for y and 16 for x. So now I've got a formula, y equals 1/32 x squared, to find me the height from the ground to the bottom of this parabolic dish, wherever I want. I specifically want, let's see, the cylinder is going to be 8 inches in in radius. So I'm trying to find out what's going to happen here at 8, 8. So to find out the height of this cardboard cylinder, I need to find out how far from the ground to the satellite dish, and then I can take whatever's left to get up to the 8 inches tall the satellite dish is to find out the height of the cylinder. So let's see, y equals 1/32 times 8 squared. So y equals 1/32 times 64. So y equals 2. So in other words, 2 is the distance, this right there, that little distance is 2. So 8 minus 2 is 6 inches. The whole satellite dish is 8 inches tall. The distance from the ground to the satellite dish is 2 inches. So therefore the cardboard can be 6 inches tall.